Hi. So I was asked a while ago to do some professional development on things like hmm, just professional development. And the only thing I could think of was to do things that were teaching styles that I had that were different from other teachers. So I did the code last year um, to try to help some teachers that were having issues with how to get their students to understand translating. And I think that's in a repository somewhere. But if you have questions on that, you can always contact me and I'll try to help you with that. And one of the things that I do differently is I teach solving equations quite differently from most people. So when I teach solving equations, I do it using this method, which is quite different from how books teach it. I do a one and done kind of system. It's the same system that I use for every level, no matter what level I'm teaching. Anybody from developmental can understand it all the way up. It makes a lot of developmental students feel better because they know what's coming up next. And it helps the people who have learned it way back when kind of refresh and they can follow along. The only people who really struggle with it are people who learned solving equations a different way and they just kind of understand that they can do it their way and still get the same answer, and they're usually okay with that because they remember it. So it's for people who don't remember how to solve equations or never learned it. A lot of times, once you've been pounded away at solving equations and you haven't been successful, you need a new way. And this is the new way that I came up with. So, teaching solving equations. Um, we have to get to the next slide. So, traditionally, students hear a lot of different situations and with a lot of different methods for solving each one. Each of these here have their own different method to go through. And then they're asked to remember all these different methods. And in addition to being asked to remember all these different methods, they have to figure out which one to use in which situation. And that doesn't work for a developmental student. They get confused about which method to use in any situation, plus having to remember them all just doesn't seem to work. So instead, we come up with a pattern. Um, they look at this, and if they're expected to figure it out, they feel like they can't succeed, and it does more damage, and it fits more into their mindset of I'm not good at math than it does in the I can do math. So we come up with a pattern that helps them be able to do any kind of solving equations problem. And I teach that pattern all the time. And when they have a pattern, they feel like as long as I know the pattern, I can go ahead and do the solving equations problem and it'll be the same every single time because it works every single time. I just have to know the pattern. Another problem with it is you have to make sure that the pattern not only always works, but will always help them. So it has to be good. If my students are developmental, they appreciate knowing that a set step is next. So there's a definite way to do the problem correctly. If they remember how to solve equations, most times this will fit into their paradigm. I never force them to do it my way. I can understand what they do and explain it to others when they deviate. That's really important. A lot of times I have students that are like, can't we just do it this way? And I say, yes, you can. That's fine. And then I explain why it works their way so everyone else can understand their way. But then I always go back to doing it my way because I want to ingrain my way for the people that are just learning it. The first line in my way is to draw the line. I always make that the first step because that has to be the easiest step. So this method makes the hard problems really easy and the easy problems look really complicated for a bit, but the more you do it, the better it gets for the student. So it doesn't matter even if the easy problems are complicated for a bit. It frustrates those that have seen the easy problems done, but it gets better for the other students and they get quicker with it. And the more they practice it, the better they get and the better they feel. So let's go over them step by step. The first one is to draw the line. I always start with drawing the line. Drawing the line means you draw a line down the equation. So right here, I would draw it down underneath the equal sign to separate the left side from the right side. That's all that I would do. I wouldn't do anything else. Where did my thing go? So we're going to draw a line. There we go. Down the equal sign to separate the left side from the right side. That way you conveniently have a left side and you conveniently have a right side. That left side will always be on the left side. The right side will always be on the right side. I make a big point about this to them. Drawing the line is the simplest thing to do. You always draw it on the equal sign, separates it into two different sides. The left is always on the left, the right is always on the right, and you have to know your left from your right. And so we talk about steps to know which one's left and which one's right. And that really is a hard thing for some people. So we talk about tricks for that, and they come up with tricks for that. So we make it a little bit interactive. So they come up with the tricks for which side's left and which side's right. So they label them because that's important later on to have them labeled earlier on. Then, once we've got them labeled, I explain to them, if you don't draw the line, I will make fun of you later. This is the only thing I ever make fun of them for, not drawing the line, because that can get them in trouble later on. Not in this section, but it can get them in trouble in future sections when I rely on the answers where the letter has to be on the left-hand side. So some of the tricks that I have later on in other sections requires the letter to be on the left-hand side. That's why I force it in this. Somebody would have asked that. Why do you force that? But that's why I force it. Step 2 is to simplify both sides. We have a couple of ways of doing that. Way number 1 is to get rid of the fractions. That means that you have no fractions. In this case, there are no fractions, so we're going to skip that step. We finish step 2 by doing B, which is getting rid of parentheses. We do have some parentheses. We do get rid of that by using the distributive property. So 2 times x is 2x, and 2 times -5 is -10. We still have a 12 on the other side. And then the last part of step 2 is to combine like terms, which means on either side, I want to make sure I have no more than one letter and one number. Now, some people would look at this left-hand side and say, wait a minute, you have more than one number. But no, I don't. Because when you have a number and a letter together, that's just one letter. And I explain that to them too. If you have 2 x's, that's 2 x's. Those are letters. Those are letters. Those are not numbers. Those are letters. You just happen to have 2 of them. That's a number. All by itself, that's a number. If you have 2 bananas, that's not a number. Those are bananas. You just happen to have 2 of them. If you have 2 apples, those are apples. That's not a number. You just happen to have 2 of them. So we talk about how 2x is a letter, and that's a number, and how that's a number. So I don't have more than one letter and one number on that side, and more than one letter and one number on that side. Then my next step says that we need to move the letter from the right-hand side to the left-hand side. Well, I don't have a letter on the right-hand side. I do have a letter on the left-hand side, but I don't have one on the right-hand side, so I get to skip that step. Then step 4 says to move the number from the left-hand side to the right-hand side? Well, I do have a number on the left-hand side. It's -10 or -10. So in order to move that, I'm going to have to do the opposite to move things from one side to the other. So to do the opposite, I'm going to have to add 10 to both sides, because what you do to one side, you have to do to the other when we talk about that. So when I add 10 to both sides, that's going to make those two 10s cancel out. And over here, I'm going to get +22. And over here, I'm going to have my 2x still. Then I'm going to divide for step 5. Divide by the number in front of the letter. The number in front of my letter right here is obviously a 2, because there's only one number in front of that letter. That's a 2. So I'm going to divide by 2. Exactly what's in front of that letter. Didn't say nothing about the opposite. Divide by exactly what's in front of that letter. So I divide everything by 2 on both sides, and you get x is equal to 11. So now we can use that in order to do some of the other ones. There we go. X plus 5 equals 3 is what it is. So I draw my line, and then I don't have any parentheses, I don't have any fractions, I don't have any like terms on either side. So I would move my letter from this side. I don't have any letter on this side. Move my number from this side. So I'm going to subtract 5 from both sides. And that's going to give me x equals -2. Over here, draw my line. Don't have any fractions. Don't have any parentheses. Don't have any like terms. Don't have any letters over here. Do have a number over here. So I'm going to do the opposite to move it. That gives me 3y equals 9. Divide by the number in front of the letter. So you get y equals 3. So far, so good. Draw my line. Don't have any fractions. Don't have any parentheses. Don't have any like terms over here or over here. Oh, I do have like terms over here. So I'm going to go ahead and do 6 minus x on this side. My like terms over here, -4 and a +2, give me a -2. I could plug that into my calculator to get it. Now that I've done my like terms, I could go ahead and say I don't have any letters over here. I don't have any numbers over here. Oh, I do have a number over here. I need to do the opposite of this number. This is a +6, so I'm going to subtract 6. A lot of students would want to say, since this is minus, we need to add 6, but we don't. We go by whatever number's in front of the 6. So this is -6 and -6. Cancel those out. Get -x is equal to -8. And then divide by the number in front of the x. The number in front of my x is -1. So I'm going to divide both sides by -1. X is equal to a +8. Over here, draw my line. Don't have any fractions. Don't have any parentheses. Don't have any like terms, sorry. Do have a letter over here, so I'm going to add x to both sides so that I can get it on the other side. Notice when I add the x over here, since I don't have any letters over here, I put it off to the side. If there were a letter over here, I would go ahead and put it underneath that letter, but I don't have any letters to put it underneath. So I just put it off to the side. That gives me a +x plus 7, because it was a +7. And over here, the x's cancel out, and I'm left with a 5. So I can subtract 7 from both sides, because you got to do the opposite to get rid of your number. That gives you x is equal to -2. Over here, draw your line. It works with decimals too. Don't have any fractions. Don't have any parentheses. Don't have any like terms. Do need to subtract the 2x from both sides. So that'll give me -2x minus 3 is equal to -1.5. Extend my line. Add 3 to both sides. That gives me -2x is equal to a positive 1.5. And divide both sides by -2. So x is equal to -0.75. Or 3/4, depending upon how you want it. Now, there are a lot of you out there that are like, there are faster ways of doing these problems. There are faster ways of doing these problems. That's exactly what your students would say. There are faster ways of doing these problems. Can we just do them the faster ways? Well, sure. In fact, there are some tips that I show my students. One of the tips that I show them is flipping it like a pancake. So, for example, let me see if I can change the color here to show you what I'm talking about. Ink color. Let's change it to a light green. If I were looking at this one again, at the, what'd you do? At the 7 equals 5 minus x again, the thing that sticks out to us is that the x is on the wrong side. It's a small equation. The x is on the wrong side. We really need the x to be on the other side. So what I would tell my students to do is to pick it up like they stick a spatula up underneath the entire equation and to flip it like a pancake. So you're going to flip it where the equal sign is. So you end up with 5 minus x is equal to 7. Flip it like a pancake. Just flip it over. It puts your x on the right side. Everything is kind of where you want it, and it's a lot less work. Negative x is now equal to 2, and you divide by -1. A lot less work. So I tell them to start looking for some of those little shortcuts, and because I can show them that one shortcut and it works faster for them, they think, oh my gosh, now I have a shortcut. Now I have a way that works all the time. And they get faster with seeing some of the other shortcuts that they can do that still give them the letter on the left-hand side, still give them the enjoyment of getting the answers right. Almost all the time, we talk about how to check their work. We talk about how you can plug it in and make sure it's correct. Everything gets talked about that normally gets talked about, and yet they are getting the answers right almost all the time. The only thing that would trip them up is if their positives and negatives were getting off. And that's a calculator issue, generally speaking. The one most people want to see is the fraction one. That's the one that scares them. That's the one that most worries you. So let's look at the fraction one. This one also works. when you get a fraction and we need to get rid of the fraction, what we do is we multiply by the common denominator. And I tell them, because they're all Twitter-pated about how am I supposed to find this common denominator. I don't remember how to find a common denominator. Well, if you stop, it's generally what you think it is. And they'll look at this and say, 2. No, it's not 2. 2 is what goes into both of the denominators. We want to know the big number. The big number that they all go into. And they were like, the big number they all go into, the big number they all go into. And they were like, okay, 4. All the denominators go into 4. And I said, even the 5 will go into 4. And so they said, the 5 doesn't go into 4. I said, the denominator of the 5, that 1, that goes into 4. And they were like, okay. So, okay, we'll do 4. So since it's 4, every single number will have to be multiplied by 4. And that's what we do. We multiply every single number by 4. So I put a 4 in front of the first one, a 4 in front of the second one, a 4 in front of the fifth one. Draw the line, whole 9 yards. So we've got how we cancel stuff out. Now the 4s cancel each other out. The 4 on top of the second one cancels out with the 2. We end up with a 2 left over. And then the 4 at the end doesn't cancel out at all. That will give you x on the left-hand side equals 2 times negative 15 is negative 30, and 5 times 4 is 20. I'm sure this isn't shocking you at all, but it does get rid of all the fractions. So there's no more scariness. Now all we have to do is combine our like terms. When you go to combine like terms, they see there is no more to do. You have x equals a number, and that was our goal, to get x equals a number. So then they're like, oh, wait, you just finished it all. I just finished it all. There was no moving anything needed. So, common questions you can get from students. How do you know how, this is the big one, the one I always get. How do you know how long to draw your line under the equal sign? Because they don't know. When they're starting out, they don't know. They need to know. They so want to know. And I always hear, yours is always the perfect length. Excuse me. It's not always the perfect length. You saw that. They just think it is. Excuse me. However, it does help that I've done it for so many years. So there's kind of a rhythm you get into, and it just happens that you just kind of know how much room you're going to need. It's your own writing. You just kind of know. Can I do it the way I learned it in high school? Absolutely. Do it whatever way you want to do it. Teach it whatever way you want to teach it. It's your classroom. Do what you want to do. There is no shame here. Do what you want to do. As long as it's correct, we don't care. Am I able to look at the steps while taking the test? No. No. You got to memorize them. Not only do you have to memorize them, you need to practice them so much that they are memorized. Second nature. Gonna happen all the time. How do I know which side to move the letter to? Well, if you follow the steps, you always go from the right-hand side to the left-hand side with the letter all the time. Letter always ends up on the left. That's why it's an L. How do I know which side is right? The L is on the left-hand side. How do I know my answer is correct? You plug it back in and check it. If I don't need a step, can I skip it? Yes. Will my letter always be on the left? Yes. Why? Because later on, when we're doing inequalities, having the letter on the left-hand side means you can do my trick. I heard you tell a student something about flipping a pancake. I like pancakes. Fill me in. So I showed you the pancake trick already. Flip it like a pancake helps a lot. But I'd never show them flip it like a pancake until they've been doing this probably through 2 or 3 different sections. So, generally speaking, when books introduce solving equations, in the very first time they introduce it, I do the whole thing for them. We go through every single step. They are solving equations every single time, just like this. All the steps that I do every single time. So I go through all of it. I don't give them just a few steps at a time. I do all the steps every single time. So when the book is doing just one little piece of solving equations, I'm doing all of it. When they go to the next little piece of solving equations, we're reviewing all of it again. When they go to the next little piece of solving equations, we're reviewing all of it again. So every time they do solving equations, I'm reviewing it again. And we get to go through it faster every time. That way, by the time we need it with word problems, or by the time we need it in some other problem, they're on it. I mean, they're going. Now, there are some people who are like, you're not really doing this with college algebra students. I am. Oh, yes, I am. My college algebra students got this. It did work. We fit in factoring into this. It goes in section 2, into step 2. It picks up into D, because that's where you would factor both sides. I'm just saying, you set one side equal to 0 and factor. So, it fits in. The whole step of factoring fits in right there as a D. So it fits. And I do this whole thing with factoring with them too. None of it changes. It's all there for them. Everything fits in. Common questions I might get from instructors. What about upper level students? Like I just said about factoring. Does this ever take up too much time? Nope. We run through it a lot faster. Takes up time in the first section, doesn't take up any time, and we run through it faster in other sections. Have students complained before? I believe over my years, and I do mean a lot of years, like 30 years, I've had maybe 4 or 5 say that they preferred a different way, that they didn't like having to do it my way. Not that I make them do it my way, but that no way compares to the number of students who have said that they finally feel like they get the problems now. They finally feel like they can conquer it. They feel like they understand it now. They feel like they can be successful now. I honestly haven't had a problem that I couldn't do this way. Some would say that it's easier to do it another way, but that they could always do it this way, and the simplicity of the process always works. It might not be the fastest way, but it always works. And sometimes for a student that seems to be getting things wrong a lot, having something that comes out right means a lot. Anyway, that's it. Thanks a lot. Bye.